So remember from 2 lectures ago that the URL that we construct could possibly accept arguments. So when you are creating your website, you might decide to create a page called hello. And when you design your page, you might say, users who visit this page are allowed to insert an argument name, and then they can provide whatever string they want corresponding to the argument name. So this is something that the server can specify, and then users on that website now know that they can load web pages with hello, with an argument at the end, and possibly get some interesting results back. So how does the website actually process these arguments? Well, we're not a web class, so we're not going to go into exactly how these handlers work. But you can imagine when someone makes an HTTP request to hello, and they provide a name argument, maybe your code has some line that says, please extract whatever argument the user supplied in the URL. And we'll assign that to some variable name. And then when we reply with some HTML, maybe the HTML that we reply with isn't just some static web page that looks the same for every user, but instead, maybe the HTML that we respond with is actually different for each user that requests it based on this argument. So for example, this website seems to say it's always going to be an HTML page. It's always going to have the word hello. But who the page says hello to depends on some string. And what string is that? It's the string that the user passed in. So basically, we've taken the user's string from the URL. We've extracted it. We've used it to construct a website that looks different depending on what arguments were passed in. And then when we send the response back, it says hello EvanBot. And if I render it in my browser, it looks something like that. So this is what it might look like if a website was handling HTTP requests with URL parameters. So now it's time to be malicious. What if an attacker didn't just put their name as the string? What if they put something like this? They still put a name, but they put these HTML bold tags around it. So what does the handler do? It takes the word hello, and then there's a blank. So for the blank, we substitute whatever the user entered. And then we write an exclamation point, and we send that back to the user. So when the user's browser receives the response, it still says hello, and then it's followed by the user's string. But the user's string has HTML tags. And if we're not careful, the browser will read all of this as HTML and then render it. And suddenly, the attacker has managed to make their name bold. Now, that was not the original intention of this website. We just wanted to say hello to various names. But now the attacker added some bold tags, and the resulting response was also bold. It's not expected. So what if you wanted to be even more malicious than bolding your own name? What are some other tags we could use? We could use links. We could use images. But I know of an even better tag we could use as an attacker. That's the script tag. Remember, the script tag says run everything inside the tags as JavaScript. So if I provide a name that looks like this, script alert1 end script, then the handler will say hello. It will substitute in the string in red, return all of this to the user. And when the user's browser tries to render this, if we don't have any defenses, it will just say hello, followed by this script. And then when JavaScript executes, we get that one pop-up. So something bad has happened. This website wasn't supposed to be able to run JavaScript from the user, but now it's running JavaScript provided by the user. And that's dangerous. Instead of alert1, you could have put something more dangerous here, like JavaScript to steal cookies, or steal a private value, or send a spam email. So something more malicious could have shown up here, but this is the general idea behind XSS attacks. So the fundamental problem with all of these XSS attacks that we've seen so far is that the user can supply whatever they want, and it's being interpreted not just as plain text, but possibly as HTML or as code. So another way to restate the XSS attack is to say the user is providing any input that they want, and the input is possibly treated like code, for example, JavaScript. And that's a danger that we have to protect against. So it could also happen with other types of string manipulation. So here, again, this is not a web design class or a Golang class, but here we used %s. You could also use some other types of format strings, and similar things could happen. So somehow we're taking the user's input and plugging it in as a string. And if that string is returned to the user and the browser doesn't know any better, it reads the user's string as HTML or JavaScript.